We are going to discuss about riverboat applications. Here totally we are going to discuss four situations. The first one is about upstream and downstream, concepts, upstream and downstream. So this is the first one what we are going to discuss. The second one is about shortest time, concept, shortest time. And the third one is about shortest path. And the fourth one is a special case where here river velocity is greater than boat velocity and is a special situation. Total, we are going to discuss four situations here. First one, upstream and downstream. Second one, shortest time. Third one, shortest path. Fourth one, river speed greater than boat speed. Like that, we are going to discuss the four situations. Now, let us see the first one here, upstream and downstream. Upstream and downstream concepts. Upstream and downstream. First application this is. Here in this application, what happened means we are traveling from boat between 2 points A and B. Here, actually the river flow is from B to A. River is flowing from B to A. If boat is traveling from A to B, that is called upstream. And the distance between A to B, let us take it as S. And here also same A to B points S. Now first, what happened? The boat went from A to B. Now boat is returning from B to A. Now, what is the direction of boat speed? Boat speed is from B to A. Already we told river speed. River speed is also from B to A. Both are in same direction in the downstream. Both are opposite direction in upstream. So definitely boat speed is greater than river speed, because whenever we are traveling with more than river speed, then only we can go front, because river speed is against boat speed. Boat speed must be greater than river speed to go against the river. So no doubt in that one, we are clear. And what is the time taken to do this phenomena means time is equal to what's the distance it travel from here to here. Yes. So we can write time is equal to what we can write now. Yes, by speed means we have two speeds. VB is there, VR is there. Both are in opposite directions. So what shall we write here? VB minus VR. VB minus VR. This is called as upstream concept. Here what we call here as downstream concept. Downstream. Yes, by what we can write here, they're going in, both are going in same direction means VB plus VR. So time to downstream is S by VB plus VR. So now we got upstream time and downstream time. Upstream time and downstream time. So here, what is the total time of journey? So we got upstream, downstream. The two things are clear. So here, observe here, upstream means boat and river both are opposite directions. River speed, boat speed, opposite directions upstream. Same direction downstream. Which time is more? Upstream time is here minus is there. So upstream it takes more time compared to downstream. And what is the total time of journey time? Total time of journey means upstream time plus downstream time. Total time of journey means just add the upstream and downstream. That means what we can write here. Yes, if you S by VB minus VR plus S by VB plus VR. S by VB plus VR. This is total time of journey. This is total time of journey, upstream and downstream. So here upstream time, downstream time. So S by VB minus VR, plus S by VB plus VR. This is the total time of journey during upstream and downstream. This is our first application. I hope you are clear with first application. Easy application it is. So both are opposite direction upstream. Both are coming in same direction downstream. Next, let us see the next application here. The second one. In this second application, we are going to discuss about shortest time. We are going to discuss the concept called shortest time. Here in shortest time, what will happen means we are traveling from one bank to another bank. This is from one point A. This is another point B. So here we are traveling from A to B. So when we are traveling, that is shortest time is also called as aiming opposite and moving. Aiming opposite. Aiming opposite. So aiming opposite here means we are traveling like this. We are aiming opposite and moving. Aiming opposite, what is the speed here? Boat speed. We are traveling in this direction. We are aiming opposite and moving. But when we are aiming opposite and moving, okay, very fine. You are aiming opposite and moving. If this is a river, So if suppose water is not moving, water is still. Okay, then we can say A and B. A and B are the points, then the boat can travel happily from A to B. But river means, is it possible the water to be still? No, water will never will be still in the river. So it will be flowing. The flow of river, let me call it as VR, is flowing with a speed VR. So because of river flow, you are aiming opposite and moving. Everybody have their aim towards the goal, but they has to reach their goal means they has to be very constant mind and doing regularly work. Like that here also, you are aiming opposite and moving. But if there is river flow, that means there are enjoyments and other things and they are pushing you away. What will happen? Instead of reaching your target, you will be went to another point. That is, if you reach the point, see here, then we can say the drift from B to C is called as X. And this is the push because of river flow. This is the push because of river flow. So there is a push because of river flow from B to C point. So what is the time taken here? Time is equal to. Time is equal to means here time can be written as distance by speed in any direction. What is the distance here? S in the direction speed VB. So I can write time is equal to S by VB. And here this is the drift distance. Actually it has to reach the point B. Because of river flow from B to C it has been drifted. It has been drifted. So the drift distance is X. So I can write now it has in this direction means X by VR. Observe carefully in the direction of X. What is the speed? VR. So I can write drift distance by VR or width of the river by VB. So I hope you are clear with this idea, beta. So this is the topic called shortest time. Shortest time. So this time we are calling it as shortest time. The shortest time is when aiming and moving opposite. What is S? Width of the river. S is called width of the river. And what is X? Drift distance. Drift distance. How much it is drifted from B to C. That is called as X. So I hope you are clear with the topic shortest time. Shortest time. Shortest time is boat is moving, aiming opposite, but river is pushing it off so that it reaches to another point. So it has been shifted from B to C. That is called as drift distance. Next. Now, shortest path. Shortest time over. Now we are going to discuss about the shortest path. Shortest path is always straight line. Shortest path is always straight line. That means here this is A, this is B. We have to reach exactly A to B. Not aiming opposite, reaching exactly opposite. Previous aiming opposite point. Now reaching exactly opposite. Reaching exactly opposite. This is our concept now. Reaching exactly opposite. So here we know that width of the river means what is the width of the river? Width of the river we denote with yes, no doubt. And here river speed is VR, no doubt. And how to travel the boat? We suppose the boat is traveling in the direction of A to B, river will push and it will be drifted. We observed in the previous case. Now we are not doing like that. Now we target in moving in this direction. We are moving against to the river flow. Now we are moving against to all enjoyments. River flow is like a enjoyment. We are going against to the enjoyments and everything. Then even they push that, then we will reach to our goal. We'll reach to our goal. So yeah, the boat is traveling in this direction against to river flow. Even river flow is pushing us. Still we are able to reach our goal point B. So this is the direction of VB. And this is the direction of VR. So what will be the speed here? Square root of VB square minus VR square. Square root of VB square minus VR square. So now what is the time taken here? Time is equal to distance by speed. S by what is the speed in the direction of S? Observe carefully what is the speed in the direction of S. So here in the direction of S, what is the speed? Square root of VB square minus VR square. How you got that one, sir? Square root of VB square minus 1. This is a right angle triangle. This is a right angle triangle. This direction is boat speed. This direction is reverse speed. So boat speed is there, reverse speed is there. And from Pythagoras theorem, what is the speed in this direction means I can write square root of VB square minus VR square. So time is equal to S by square root of VB square minus VR square. Now you observe one more point. It is making an angle theta here. Theta here. Theta with respect to the perpendicular on boat speed. Theta with respect to perpendicular to banks. These are the two banks. This is one bank, this bank. Perpendicular to bank. Theta is making angle with perpendicular to banks. Perpendicular to banks. And now this is VB. This is VR. What is the formula connected with VB and VR? You observe this triangle carefully. This is one triangle. In this triangle, this angle is theta means opposite to theta I have VR, hypotenuse I have VB. Opposite to theta I have VR, hypotenuse I have VB. What is sine theta? Sine theta means opposite by hypotenuse. Sine theta means opposite by hypotenuse. So here I can write sine theta as sine theta is nothing but what is sine theta I can write here? Sine theta is nothing but VR by VB. Sine theta is nothing but opposite by hypotenuse from the triangle here. In this triangle, theta opposite VR, hypotenuse VB. So sine theta is VR by VB. Okay, fine. Sine theta is VR by VB. Then what is theta can be written as? So you know from trigonometry, sine theta is VR by VB. And theta can be written as sine inverse of VR by VB. Sine inverse of VR by VB. So this is the direction. This is the direction. Theta is direction with respect to perpendicular to the banks. Both direction with respect to perpendicular to the banks is theta. But I want direction of river flow. See, observe here. This is the direction of river flow. So I want direction with respect to river flow. Direction with respect to river flow means observe here. This theta is only direction of boat with perpendicular to the banks. Perpendicular to the banks. I want direction with respect to river flow. Direction with respect to river flow. Boat direction with respect to river flow. What is the angle here? Mean this total angle. Total angle we have to take from here to here. So that is 90 plus theta. Now observe carefully this point, very, very important point. 90 plus theta is nothing but direction of boat with respect to river flow. Direction of boat with respect to river flow. Direction of boat with respect to river flow. So they are asking with respect to river flow means we must not take simply theta. We have to take 90 plus theta. Theta is also direction but perpendicular to the banks. Direction of boat with respect to perpendicular to the banks. 90 plus theta is direction of boat with respect to river flow direction. With respect to river flow direction. I hope you are clear with this shortest path concept. So what is the time in shortest path? S by square root of VB square minus VR square. So in shortest path means we are going against to the river flow. Even river pushes the boat, we can reach our target point, reaching exactly opposite point. This is our aim, our goal. We are reaching our goal by going against to the river flow. We are able to reach the point. In all these cases, boat speed will be greater than river speed. Boat speed will be greater than river speed. Now we are going to discuss one special situation. In this special situation, river speed is greater than boat speed. River speed is greater than boat speed. So when river speed is greater than boat speed, river speed is greater than boat speed. Here let me observe carefully here. 2 points are there. This is A, this is B. Now what happened means, carefully how to observe these points. Now river is flowing in this direction, no doubt. We are happy river is flowing from left to right in this direction. And boat is traveling in the against to the river flow. Okay, boat is traveling against to the river flow. But here in previous case, boat speed is greater than river speed. Now boat speed is less than river speed. If boat speed is greater than river speed, then the boat will be pushed in this direction, but still we can reach the point here. But boat speed is very less compared to river speed. So as compared to river speed is very less, it will be pushed away again and it is drifted to the point C. Actually, we are going against to the river flow. What happened? When they push, will reach the point our exactly opposite goal. That's the B. But their push is more. So we are shifted to the point C. So now observe carefully here. So between B to C, there is a drift, X. And width of the river, we'll call it as S. And S is, we know that width of the river, X is a drift distance. It has been drifted to here to here. So now observe the speeds. In this direction, we have VR. In this direction, we have VB. VB is in this direction. VR is in this direction. And let us take here small angle it makes here to here is theta. Now I know resolving a vector into components. I know that if a vector is like this VB and this angle is theta, if I resolve into components, I can write this as VB cos theta and VB sin theta. Resolving of a vector into components. So this is direction VB means in this direction VB cos theta, in this direction VB sin theta. So resolving of vector into components by that method. Now what I am doing here, I am resolving that VB into its components. The component in the direction of perpendicular to the banks is VB cos theta, VB cos theta. And the component in the direction opposite to river flow here is VB sin theta, VB sin theta. Observe carefully here. VR and VB sin theta both are in opposite directions. VR and VB sin theta both are in opposite directions. Now, first of all, what is the time taken? We know that whenever we use the term time, time is nothing but distance by speed. From here to here distance is S, and from here to here speed is VB cos theta. So time is equal to distance by speed means I can write S by VB cos theta. So time is equal to, I can write S by VB cos theta. We are happy regarding this time, S by VB cos theta. Because time is nothing but distance by speed in the direction. In this direction, distance is S. In this direction, speed is VB cos theta. But for X, we have two speeds. X is horizontal. In vertical, only one speed VB cos theta. But in horizontal X, we have two speeds. One is VR, other one is VB sin theta. In horizontal, we have two speeds, not one speed here. In horizontal drift distance X, we have to discuss about both VR and VB sin theta. We have to consider here. So here, what is X? X is equal to the distance, X is the drift distance, is equal to speed into time. Observe carefully. In this direction VR, in this direction VB sin theta. Both are in opposite directions. So X is equal to VR minus VB sin theta into time. Into time. So this is the formula what we have. X is equal to VR minus VB sin theta into time. Why you wrote VR minus VB sin theta, sir? Because both are opposite. VR and VB sin theta are opposite. I want X. In horizontal, we have two speeds. So what the net speed means? VR minus VB sin theta. Some student can ask now, sir, why didn't you write VB sin theta minus VR? You can write VB sin theta minus VR also now, sir. Why you wrote VR minus VB sin theta? Observe here. VR is greater than VB. VR is greater than VB means, obviously, VR is greater than VB means VR will be greater than VB component. VB sin theta is VB component. VR is greater than VB means, obviously, VR also will be greater than VB sin theta. Both are in opposite direction means I can write VR minus VB sin theta. So X is equal to VR minus VB sin theta into time. Time is nothing but S by VB cos theta. Let us observe here. X is equal to VR minus VB sin theta into time. Time formula from above, because simultaneous action. Either we are taking from here to here or here to here is a simultaneously the boat is traveling here. So S by VB cos theta. Time is same. S by VB cos theta. So here in this record, what we observe here is X is equal to VR minus VB sin theta into S by VB cos theta. This X is called drift distance. This time is called the time where it is shifted from B to C. So time is S by VB cos theta. X is VR minus VB sin theta into S by VB cos theta. These are the situations for riverboat concepts. So let us see what we discussed here. We told riverboat concepts, first one upstream, downstream, second one shortest path, we are greater than VB, four cases. See the first case here, so that is upstream, downstream. In upstream, downstream, upstream means both speed, reverse speed opposite. Downstream, both are in same direction. Here we got S by VB minus VR, opposite direction. Here we got S by VB plus VR, both are in same direction. This is the information. This is short total time of journey from A to B and again from B to A, total time of journey. Next, here now shortest time concept. Shortest time is, remember, aiming opposite. Everybody have a aim to reach their goal, but because of river flow, the boat even is traveling in this direction. River flow pushes that boat, and we are reaching the point C. We are drifted from point B to C. The distance is called drift distance. That is X. And width of the river is yes. Time taken in shortest time concepts. These are shortest time concepts here. What is time? Time is the distance by speed in any direction. In this direction, vertical, yes. In vertical, speed VB. So S by VB. In horizontal, it is X. It is VR. X by VR. It is a simultaneous action. Either you take in vertical or horizontal simultaneously. Body is moving in vertical and horizontal. So either time in this is a vertical or horizontal will be same. And with this formula, we'll be solving the all objective questions. S by VB equal to X by VR. Very, very important for objectives. Next, here if you observe shortest path concept. Shortest path concept is nothing but That is reaching exactly opposite point. Reaching exactly opposite point means if you go A to B straight, they'll be push you. So you are going against to river flow. Even they push because of board speed greater than river speed. Even they push, you'll reach the point B. You are going against means they pushes you also. You'll be able to reach to the point B. This is called as shortest path concept. Reaching exactly opposite point from A to B, exactly A to exact opposite point B. So here time is, this is VB from Pythagoras theorem. This is square root of VB square minus VR square. So time is equal to width by square root of VB square minus VR square I can write. And here this is theta is there. This is one triangle I can find. How VR and VB connected means I can write sin theta is opposite by hypotenuse. VR by VB. Theta is sin inverse VR by VB. Here, so theta we got. This is the direction of boat. What is theta? Direction of boat with respect to perpendicular to banks. Perpendicular to banks. But actually in objectives, I found so many times they're asking the question, direction of boat with respect to river flow. With respect to river flow. River flow means this is the direction of river flow. With respect to river flow means this angle is 90 and this angle is theta. So 90 plus theta is direction of boat with respect to river flow. 90 plus theta is direction of boat with respect to river flow. See here, 90 plus river flow, boat. 90 plus theta, 90 plus theta. Theta okay. Sin inverse VR by VB. This is a concept for shortest path concept. Next, let us observe the last case. River speed is greater than boat speed. River speed is greater than boat speed. So here, river is flowing in this direction. Boat is moving against to river flow in this direction. So we can resolve into components. Here VB cos theta, VB sin theta. Remember, always where angle it makes, remember this point, where VB is making angle to vertical, that vertical will become cos term. If angle made to horizontal, horizontal term will become cos. But here it is making angle with vertical. Vertical term is cos. Vertical term is cos. Another term is horizontal. So from here, this is the width, yes, and this is VB cos theta. Time is equal to, I can write S by VB cos theta. Time is equal to S by VB cos theta. So X is equal to VR minus VB sin theta into time. How you got this formula, sir? Okay, time is width of the river. Yes, in this direction VB cos theta. Fine. Because same direction, distance by speed. But when we are discussing about X, X is horizontal. Horizontal, we have two speeds. One is VB sin theta, other one is VR. Two speeds are then horizontal. No doubt VR is greater than VB sin theta. So horizontal distance is equal to VR minus VB sin theta. Because opposite directions, we have to take subtraction. Which is greater? VR greater than VB sin theta. VR minus VB sin theta into time. Time is S by VB cos theta. So I hope you are clear with these ideas of river boat problems better. So we'll continue on next class in our next sessions. Thank you very much.